take a look at where we left things off with our work. So split our screen. We have hello world. So we had the ability to load all of our jokes and to load one joke. Let's go now to where were we? Here's our, so we had added the ability to get one joke from our database and to get all the jokes. Now let's work on creating a joke. So for creating a joke, we're going to switch away from gets and we're going to go to posts. So we're going to post to /jokes. And what we're going to ask for is we're going to ask for the params for the joke. And we're going to use the create method on joke, which normally takes a hash, a dictionary of things like the punchline, right, and haha, right, the actual punchline of the joke. But here, this hash for the parameters are going to become part of the create are just going to come from the joke params. We're going to take the params that come in as the joke. We're going to see what that looks like when we hook it up to the Postman. Those params are going to become the input to create. Because normally a manual create would look like this. Right? So this params joke means that our input will look something like this, right? It'll be an object that has a joke that is a punchline joke here, right? This should look kind of familiar to your API inputs that you were doing before, right? Like when we were creating one list and we were sending it text, right? This would be item and text, same kind of thing. This style of object for creating should be a little bit familiar if you go back to one list. What's going to happen now is that we're going to pull this params joke, essentially will give us this. And isn't this the same thing that we need to pass to create? Right. See that? I'm sure you've got a question.
Yes. Do you need that parentheses and squiggly brackets?
In this example here, no.
No?
Most of the time we write it like this.
Okay.
Right? So since we're just taking the punchline and the joke, right, that will be this part of our input. Right. Let's take the result of that, which will be the new joke in our database, and respond with the new joke. So we'll respond with an object that is joke is the new joke. This is going to end up looking a lot like how our one list was working, if you remember what one list looked like. So let's go into Postman instead, because now we're doing some more complicated things that we can do just in the browser. And let's try our API from Postman. Right? Just like when we had one list, we were doing API requests from Postman. We're going to do the same thing here. So let's go to localhost 4567/jokes and see what we get. Right? We should get back our list of jokes. Right? And if we make a new request for localhost 4567/jokes2, right, we should just get the one joke. Right? This should be a lot like how we had OneList API. We can wake that API page up. It would look a lot like this, right? /items returned a whole bunch of things about the items, right? /items returned a list of items, right? Bracket object ID text, right? Items bracket ID punchline, right? If we didn't want the jokes part of this for all, we could just return all the jokes, right? And now we don't even have the initial object. We just get an array of objects, right? Just depends on what the shape of your API needs to be. So now if we're going to create a joke, right, this is going to be a post to our 4567. That's where our Sinatra app is. Jokes is our endpoint. We'll make the body a raw JSON. And what we said is we want a joke that has a punchline, right? And we'll put a joke in. This should be a lot like when we created a new item. It's a lot like this, right? When we created OneList, we were using the OneList API. It's an object that has an item and text. Here we just have joke and punchline. So if we do this, and if we did it right, did we get a response? We did. We got joke 3, but the punchline was null. So let's see if we can figure out why the punchline came back as null. Right, the response came back joke ID 3 punchline null. So in our post jokes, we were asking for the params joke. So to debug this, here's what we're going to do. We're going to use our friend P, the programmer's print, and we'll just print the params. Let's see what's inside of params. So we'll add some debugging here to post jokes, so that in our terminal, which is over here, we can see what our params look like. Because for some reason, we're getting nothing for our joke. So let's go back to Postman and send this again. So we're getting more entries in our database, ID 4, but the punchline is blank. So let's see what our params look like. Ah, they're empty. So let's see if we can look and see why. Here are the params. Oh, do we really have to do this? So let me see what's going on here. The params here may only be for the URL parameters. Let's see if this little bit of code here does what we want. So what this is saying potentially is that we have to read the body Yeah, here's the joke and the punchline. So I thought that the JSON that we brought in here, the Sinatra JSON, would do this for us. But in order to get the body, we have to read the request body and then parse that as JSON, and we'll get that back as data. And then we can ask the joke params from that. I'm going to research this. Because what we're doing here is we're saying this request object is kind of like the params, but it's the entire request. So it's the headers and the body and all the details. And then we're saying from the request, go get the body, the main part of the request, and read it, but then process it as if it were a JSON. And that gives us back this. And it gives us back this hash, right? This dictionary. Joke is an object that has a punchline that is this. And then from that, we'll take the joke, and that's what we'll pass to jokes create. And now I think we'll have what we need. If we send this, yeah, now we have the joke being created. So we had to do a little bit more work. We had to read the request body and process it as if it were JSON, and then take the joke element out of that. I think there's a simpler way to do this. I will look it up. I thought that the JSON library would do that for us, but it doesn't. Right? And now if we come back and look at all of our jokes, right, we're going to have a few in here that were null from the time that we weren't sure what we were doing. And then here's the one that we just added. New. Why can't I type? Oh, because this is the result. New joke. Right, let's send this new joke. And then let's get all of our jokes. And there's our new joke in the database. Right? If we went to the console and we did a pgcli jokes, right, there's our new joke in the database. Right? Similarly, if we added a joke here, we would end up seeing it here. Right? If we go to 4, 5, 6, 7 jokes. Right? So this is adding a joke. Let's update a joke. So the update will be a put, and the path will be jokes and the ID. Right? If you remember when we were dealing with OneList, it was the same thing. It was a put to items ID, and we passed in the item and the fields we were going to change. So this put will work a lot like the post to create. We're going to take the data from the joke, but now instead of creating a new joke, let's go find the existing joke. So the existing joke will be joke find based on the ID that we get from here. So joke/7 will be the joke number to find, and that will give us an existing joke object, right? Just like you did the other day when you said joke find 3, or whatever your example was, probably like animals find 3, or seen animal, whatever it was in the Safari homework. Now that we have the existing joke, we're going to update it with the joke params. Right? Find the joke by its ID. Update it with the new parameters from joke params. And then we'll just end up doing the same thing. We'll just render back the joke. Same thing, we'll parse the JSON input, we'll get the joke element, Now instead of doing a create, we'll find the existing joke by ID, and then we'll call update on that joke, passing it the new joke parameters. So if we add in another here that is a put, let's go to jokes. Oh, we gotta go to localhost jokes. And what was one of the joke numbers that we were missing? Joke 3. Okay. And in the body, we'll make it JSON, and we'll say that the joke is now punchline finally a joke. Okay. So the same form as the post, right? We're going to give it the same thing, an object that has a joke that has a punchline, so that when we get that joke from the JSON on the server, we'll have this back. This is what's going to end up in joke params. We'll find that joke by the ID, right? The ID that's in the URL, the ID that's in the URL. So we're going to find joke 3 by ID and then update that to the new joke params. So if we send this, we should get back a result, and it's going to return us the same joke. But now, if we come back here and we get all of our jokes again, it shot it to the bottom, right? Finally a joke. So remember the other day we said like the data is going to come back in any order? Let's fix that. Let's go to our jokes, and here's where we get all the jokes. Let's order it by ID. So if we just add an order clause on the end of joke all, now when we get these jokes, right now the 3 is in its place. Because we told the code to always give me the jokes in a specific order, right? If we did it by punchline, it would sort them by punchline, but let's just get them back 1, 2, 3, 4, 5, 6. So we just say joke all order by ID. So here's our creating a joke. Here's our updating a joke. Finally, let's add deleting a joke. So that's going to be a delete to jokes ID do. So let's find the deleting joke by saying joke find params ID. Let's find it by ID. And then the method that we call is destroy. And that's the active record. And then, again, let's just return the joke we just removed. Right? Let's give the user a chance to see the joke that we just removed. So this is going to work very much the same way. Delete jokes and the ID, get rid of it. So let's delete joke 4, that one that we put in that was bad. So let's add a new request. This is a delete to localhost 4567, and we said joke ID 5. Okay. And if we send this, right, there's the joke we deleted. And if we come back to our get all of our jokes, we should see joke 5 being gone. And it's gone. And if we come back and we say jokes 4, and we delete that one, and we come back here, and joke 4 is gone. So this is pretty close to the OneList API. Right? If we change jokes to item and punchline to text, it's pretty much the implementation of something much like OneList. There's not much here that we don't have. We need a complete Boolean in addition to the text, but this is probably a lot like what the code for OneList looks like. And I think Jason did it in Rails, not Sinatra, right? But I'm sure the code is pretty similar. Right? So we have create, read, here's read, here's create, here's update, here's delete. right? This is a full CRUD application. If we wrote a little React app that pointed at our host, localhost 4567, we could make a little joke management system, list all the jokes, get a specific joke, update a joke, delete a joke, just like we had a list management system when we made the front end for OneList. Right? So this is pretty close to what would be the back end that powered our OneList front ends. Right? We just end up having these several actions: create, read, update, and delete. Okay. And when people talk about this idea of RESTful, you'll hear this term REST and RESTful. The idea is to have a canonical, meaning representational, set of URLs that manage a resource, right? That represent the state of something, in this case, our jokes. So we're saying to the world that if you ask for the resource jokes and you get those, we will always transfer to you the state of all the jokes we know. Right? And we said that that's an idempotent request because we can keep asking for the jokes. Right? The list of jokes may change, but the resource, the conceptual thing we're asking for, the list of jokes, is always the same. You ask for a list of jokes, I give you a list of jokes. It might have 5, it might have 100, it might have 0, but I'm always going to give you the list of jokes. And then the pattern of these URLs, posting to jokes, right, says, well, if I am able to get the jokes from getting /jokes, then posting to jokes should let me create one. So jokes here is the resource. Get jokes gives me the list. Post jokes creates one. Putting a joke to a specific joke ID changes that joke, and delete that same URL will remove it. Right? So the concept of REST itself is pretty complex, right? You know, it's got all these rules and whatnot, but the thing that you should think about is that if every item in your project, in the thing you're trying to build, can be thought of as some resource that can be created, read, update, and deleted, then that should match to a set of URLs that allow you to create, read, update, and delete them. Right? So if we had jokes and we had authors of jokes, right, or joke writers, maybe we'd have another set of URLs that would be /writers, and that would give me all the joke writers. And /jokes7 would give me ID 7 of my writers. And posting to /writers would allow me to create a joke writer. Mm-hmm. And then you might look at something like Toby was looking at in the Star Wars API, where maybe if we wanted to represent the joke, who wrote the joke, we've got two choices. Either we can give the user the writer ID, like what's the ID of the person who wrote this joke, or we can give them the URL to where that resource exists. Right? The entry in our JSON response here, right, could be either the ID of the writer, right? If we took all of this, we imagine what it might look like if we had an entry for the writer, right? We could either have writer ID, right, 42, or you might have something like the writer URL, and that might be localhost 4567. Right? Either of these would be a way to say, for this joke, come on screen, for this joke, who wrote it? Right? Here we just tell the ID, and you have to know to go to /writers/42. Or we can give the URL. So REST also has a way of representing relationships between things, much like our database does. But there are no rules for it. You'll find that each person who creates their own API is going to represent the data in a slightly different way. And there are some standards for this. There's a standard called the JSON API that dictates how you relate data from one model to another. And it kind of follows the rule a little bit like what you had, Toby, with the Star Wars API, that kind of follows the JSON API style, which would be to do something like this. Just tells you which URL do you go fetch to get the details for this writer. We haven't created that system in our database yet, but this is how it would kind of work if we were to do so.
Would you normally, for the writer, create another table and then join it and stuff like that?
Yep,
Okay.
absolutely. Yep. If we were then going to add the authors of these jokes, we'd have to have a separate table to store their names. We'd have to have a one-to-many or many-to-many relationship between joke and author, right? Or maybe a one-to-many. One joke is written by one author, but an author can write many jokes, one-to-many, right? We'd have that join, and then we'd have code. We'd have a whole nother set of entry points here. We'd have /authors or /writers, /writers ID, post writers, put writers ID, delete writers ID. So for every resource that your system manages, you're going to have these endpoints and these URLs. Right? And then the relationships between them get expressed how you want, either by ID number or by giving the URL to what URL your front end would have to fetch in order to get that data. Right? We're going to talk more about REST when we cover Rails in detail. Sinatra makes no specification for how you deal with your resources. When we get to Rails, Rails follows the REST pattern. So out of the box, it gives you all of these APIs. Create, read, update, delete. You kind of get those endpoints, those routes for free.
So we won't have to require Sinatra?
No. Yeah, so we're only using Sinatra as kind of a gentle landing spot onto APIs. Because you'll see that in this Sinatra app, like our entire application is in one file. When we get to Rails, which we may do tomorrow or we may do on Thursday, we make a new Rails application, there's hundreds of files. Well, not hundreds, there's dozens of files. We kind of have to walk through what a lot of these files do. Sinatra allows us to get sort of this introduction to APIs in a way that we just have kind of a one file solution. Sinatra is what we call a micro framework. It's a very, very small framework that allows us to do quite a bit. But the more features we add to our app, the closer and closer we get to having something like Rails. Right? So we don't have anything for natively supporting multiple routes. We don't have anything for supporting authentication. We don't have anything for supporting a whole bunch of things that Rails gives us kind of out of the box. If we added all those things eventually to Sinatra, we'd end up with something as big as Rails. Right? So you can kind of think of them as Sinatra is kind of a very small tool that does one thing really well, like a sharp scalpel. And Rails is kind of like the Swiss Army knife. It's got everything built in already. So what I'm hoping to sort of show you is we started with databases, right? Creating databases and writing SQL. Then we took a look at Active Record to kind of simplify the SQL. Now we're looking at something like Sinatra, which is allowing us to have interaction with the web, right? Implementing the backends that we've seen already, right? This should feel a lot like OneList, right? You could probably take all the jokes and change them to items and take all the punchlines and change them to text. And I'm betting if you ran this under localhost 4567 and pointed your OneList front end to it would work. Right, you'd be able to have your OneList just running locally, your front end pointing at your back end. Guess what? That's how your final project's going to work. Right? If your back end is pretty simple, you could write it as a Sinatra application. If you're just managing 2 or 3 resources and it's just an API thing, you're not far from having all the things you need here. Right? Add some more complication, use authentication, some uploading, what we need, the extra ability of Rails. But what's nice is Rails will make some of these things simpler. So again, give and take.
Is Active Record built into Rails?
Mm-hmm.
Yeah. Okay.
Yeah. So the secret of Rails is nothing more than a growing number of existing gems bundled together. Right. The Rails team wrote Active Record. But all the parts of Rails you can pull apart and use in different projects. But when you mix them together, you get Rails. So Rails is active record and active support and action view and a whole bunch of other gems that just kind of comprise Rails.
Ruby's holy grails.
Yeah, yes. Yeah. So now what's funny is there is a project called Grails, which is Rails for the Groovy language.
I was going to say, well, I had a joke in my head one time. What about Groovy on Grails?
Yeah. So there is literally, yeah, you're not far off because there is a language. Apache Groovy is a Java syntax compatible object-oriented language. And there is a Grails framework. A powerful Groovy-based web application framework for the JVM built on top of Spring Boot, which is kind of a little bit of an homage to Rails. Rails, Grails, Ruby, Groovy. So everybody rips things off. Ask Mike Nash, because I think he did Grails. He did some Grails work and Groovy work. Alumni Mike. Right? So kind of the beginning of APIs, right? Create, read, update, delete, integrating Ruby and the web and databases together.
You might have answered this for me last week, like deleting _joke. Is that Taco Tuesday or is that? Okay.
It is.
And then so destroy and delete that comes from sorry, I just went blank.
Yeah, the destroy here is the name of the method on our joke object that active record is giving us.
Okay.
Yeah, so because we said that the joke class is an active record base, that gives us joke.all, that gives us joke.find, that gives us joke.create, that gives us joke destroy, right? Because our joke class is an active record database model, it gives us all those features. So for instance, for delete, this is the name of the HTTP verb. What kind of web request are we doing? This delete is not a Taco Tuesday. It lines up with this delete here. We're doing a delete action on this URL. If instead this was a put, I would be updating joke 4. Right? You can see that here. I'm updating joke 3. Right? So this verb is one of this list of things we can do: get, post, put, patch, delete, copy, head, blah, 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 blah. Right? We mostly just use get, post, put, delete. Right? But there are some others that we can look at. Right? So this and these are not Taco Tuesday. This comes from active record. This is just matching the HTTP verb that Sinatra is allowing us. This is a thing that comes from Sinatra. Sinatra added delete, put, post, get. Those are Sinatra words that come from requiring Sinatra. Right? The find comes from active record, and we just pass it a number or a string representing a number of which joke we're asking for. Right?
Oh, so we didn't define delete or any of those. That's a keyword.
No. Yeah, this delete here comes from Sinatra.
Yeah.
This says, hey Sinatra, when you see a delete on a thing that matches this pattern, this is the code to do. Much like Shay said earlier, this is kind of like on the front end side, it's kind of like React Router. Except React Router only has this part, right? It only has this and the code to run, or the component to load. On the back end, we can say, hey, match / joke / anything, but when you get a delete, I want you to do this. But when you get a put, I want you to do this. So even though this URL and this URL are almost identical, right? Jokes 3, jokes 4, jokes 3, jokes 4, this is a delete joke 4, which will cause joke 4 to be deleted from the database. This is a put to jokes 3, which will replace the joke that has ID 3, right? That delete lines up with this delete, and that put lines up with this put. So you'll find in pretty much every REST application you do, you're going to have get, post, put, and delete. You're probably going to have those 4. When we get to Rails, we're going to have a couple of extra ones, right? Because here we're only doing an API. what if we were doing a monolith where the back end is also serving up the front end? Right? So we've talked about having an API that feeds a front end. That's one style of development. The other style of development is where your Sinatra or Rails also provides the front end. Right? It's also the thing that's generating the HTML for the user. In that case, there's a couple extra endpoints we add. One of them is to show a new form, and one of them is to show an update form. Right? And we'll take a quick look at that this week or the week we get back for anybody who wants to do a monolith style application, which is totally fine. If you don't want to do a React app and a API style, if you want to do an all-in-one style, that's also okay. I think at least one student did that for their Rails application, or they did part of it as an all-in-one. Shay?
For your final project, does it look better to do the monolith or do React with Ruby?
It kind of depends on what you're trying to do and what you feel comfortable with. Both are fine. You can actually kind of mix and match them on the Rails side too. You can do some of your work in React and some of it in straight Rails. Right? So Rails kind of gives you that ability to blend them both together, because you can have React components inside of a monolith. Right? Instead of like, hey, I'm just doing everything in Rails. I don't want to have a separate app thing. I'm just going to have everything in a Rails app. You can still have React components inside of there. Or you can do a pure API and a front end. I think if you didn't have any reason other than, I would say probably do a React app and an API, because that's what you have the most experience with. I think maybe it was Ben did, or I'm not sure. Maybe Matt did. They had a React application as their front end with an API, and then like their admin feature was a pure just Rails form generation monolith application. They kind of did a little bit of both, because it's really simple to have an admin application. When I show you Rails, I'll show you kind of the scaffolding and how to build up like an admin kind of site. And then you can do that. Yeah, you can do both. Yeah. If you can do an API and a React app, then the all Rails thing is like, oh, if you know how to do that, then the monolith Rails thing is easy. Because the API is getting you probably 90% there to doing a monolith anyway. Yep. So this is probably a good representation of the things that we're asking you to do for your homework tonight, right? Create, read, update, and delete a whole bunch of database records, all right? So probably start with this, right, and kind of see how this works, play around with it. Try creating your own jokes, right? Deleting, updating, and then see if you can replicate that. I think on tonight's homework it says one of the adventure modes, or maybe epic mode, is to hook up a React front end to it. Try that. I think you will find that even if you build a very simple React front end that uses the API you just built, if you can do that as a homework, that is literally 90% of like what we want you to be able to do on a final project. Build an API, figure out the design of something, build the API for it, get that working, create, read, update, and delete, make a React front end that points at it, right? Don't make it fancy, don't make it pretty. That's essentially what we're asking you to do on a final project, just bigger, more features, more resources, with a login, with uploading images, with putting a map on the screen, or making a searching thing, right? But at the core, that's what your capstone project is.
So we just do an Axios, and then same as we always.
Mm-hmm. How much time do we have? We've got time. Let's do this. Let's try it. Let's do this. Let's take this app, create, read, update, delete. Let's copy our hello world and let's call it onelist.rb. Let's create a database called onelist. create a table called items. That's an ID, that's a serial primary key. And it has text that is text, and it has completed that is a Boolean. Right? I think those were the things that our one list had, right? Had an ID, had a column called text, and a completed. Let's insert into items text and completed values, write an API, and it is not done. Here's our one thing in our one list. Let's copy hello world. Did I already do that? I did. Let's edit one list now, and rather than have it say jokes, let's have it say one list. So everywhere where it said jokes, everywhere it said jokes, let's have this change this to one list. This joke is an item. Let's get rid of this stuff here. That was our little demo. Instead of jokes, we'll say items. Instead of jokes, we'll say items.
Doesn't no items disconnected to that?
It does, because they said it right here.
Okay.
Right, so I changed the database to one list.
Yeah.
Instead of a joke model, I have an item model, right? Because that's what's in my one list.
What was your table called again?
Items,
Oh,
plural.
okay, my bad.
Yep. So instead of all jokes, it's all items. Instead of this is an item for the database.
You'll have to branch this in order to commit it though, right?
No, because I copied the file. Remember, this one's called OneListRB, and the other one was called,
I missed that.
yeah, the other one was called Hello World. So items, item, text. So all I'm doing is changing joke to items, basically.
Still
Do I have a joke somewhere?
JSON joke item from database. Right there.
Oh, thank you. Right, and really a lot of these jokes that are variables are Taco Tuesdays. The only thing that really matters are the things that are in parentheses and the model name, right? So this is joke params. Nope. Item params. This is an item. This is an existing item. 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 Item.
It's fine,
Item.
case sensitive.
It is not.
Okay.
But I want
It says
to.
item 0 right there on
Oh,
JSON.
thank you.
How are you selecting the word the way you are?
I'm using a Vim trick. I'm doing change inside Word. But if you're in here, you can say edit. Where is it? Selection. There's a select a word. Edit. What is it? Selection. Expand selection. Command Shift P. Select word. Word? Isn't there a word selection? Select. Command Shift P. It's probably this then. Selection. Expand selection. Right.
Oh,
Which is Control, Shift, Command, right. But in Vim, it's change inside Word. And it gives me the ability to change that word. My brain is trained for Vim, but you all use VS Code. So I actually have a Vim mode inside of VS Code. So it looks like VS Code, but all the commands I'm typing are Vim editor commands. It's pretty much the only way I can effectively type. So hopefully, Thank you. Get all the items.
29, 20.
And item. No more jokes. Ha ha ha. So all we did was change joke to item pretty much everywhere. And we changed the database to one list. So if we run this, let's go back. Week 6, day 2, one list. Let's edit this. And let's see if we can find where we put that URL. So here's our app. And now I think all we need to do is make this say HTTP localhost 4567. And this will be HTTP localhost 4567. And is that it? That's it. Just change those two URLs from the one list to our local one. Let's see, yarn install. Because I cleaned up my yarn, my node modules. And what we should then see is requests come into our one list backend coming from our one list front end. Let's see. It's thinking about starting. When it starts up, we should see a request for /items show up here. Hey.
We have to run both of them to make it actually work,
Mhm.
unless it's deployed.
Yes, so in one terminal, I'm running my Ruby API, and in the other terminal, I'm running my one list. And we got /items, but we didn't see anything here. Let's see if we can figure out why. Because we should be able to get this to work. Let's reload the app. Here's our items.
Do you need access to them?
No, because I don't have the same thing where like we can have support multiple lists yet. It asks for /items.
You still have access token on there.
Yeah, it's fine. That should be okay. So let's go over to our one list Ruby /items. We didn't get anything back. So let's go to Postman and let's change this to items. Maybe it wasn't text. No. ID text complete. ID text completed. Complete versus completed. Boo. All right, let's fix that. PG CLI. One list. Let's see if that's our problem. Alter table items, rename completed to complete. Does anybody remember the syntax? It's alter table items, rename. See how
Do you have etypes too?
do I have to type the word to? Yes, cool. Let's see if this works. Let's see if that was the problem. Ruby one list. So here's our Sinatra app running. And if we reload our one list, nope. Oh, cores. Cores. So remember when we had those APIs that wouldn't let us use them from the web? It's the same thing here. So,
And there's a special one for Sinatra.
yeah, there's a way to turn it off for Sinatra. Um, let me see, is there an official way of doing it? Well, it looks like we have to use an extension. Let's see if we can find. Let's see if we can find it. Nope. So let's try this.
Is that the special search? The search through the website?
Yes. You type the word space site colon and the site you're trying to search. So it looks like there's a gem for Sinatra cross origin requests. So let's add that gem. And then it looks like you require this at the top of your code. And then you say register and enable. Let's see if this works. Nope. Oh. Shoot. Bummer, bummer, bummer. Bummer, bummer, bummer. That did not work. So it's the course thing getting in our way. I really wanted to show you this working. Let's see if this way will work. We will do this. Let's try this way. Nope. Right cores. This course thing turns out to be more of a pain than it's worth sometimes. Okay, let's see if this works. Nope. We'll try one more time. One more thing to try, and that is allow resources. This. Let's try one more time. Nope. All right, I will figure it out, not during lecture time, how to get the core stuff to work. Because this is really all we should have to do. I just don't remember how to get cores disabled in Sinatra. I know how to do it in Rails, I just remember how to do it in Sinatra. But this is really all we should have to do, because this is the same the same API that OneList had. This is a bummer. Allow origins all, allow resources. What if I just say allow resources star? Let's try that. Then I'm really going to give up. Worked. It worked. Okay, cool. So all we had to say was we changed everything from joke to item, and we added this cores, allow anyone to access our API via browser. Right, this garbage here. We should be able to make a new app. You know what? I think we may have left this.
We didn't fully complete.
We didn't fully complete it, yeah. We didn't fully complete it. So somebody else had their OneList done. I think there was just one thing we had to finish in here. Do I have another OneList API running somewhere? Nope. Yeah. I think we were like in the middle of a change, and we didn't finish it.
You got us started on that homework is what it was.
Yeah, okay, cool.
And you pointed us in the right direction.
Right. New item, items. Right. And we tried to do this funny thing where we were like changing the text and we were trying to edit it in place, but we didn't really get somewhere with it. Right. But if we go in and make a new insert into items. Complete. Yeah. This. Yarn start again. Right. Right. There's our two items. Will this work? Yeah, we don't have that. It's not working either. Right. So, right. Hopefully we see now what's on the back side of that OneList API is this 80 some odd lines of code. You know, a certain portion of it is comments. Right. That's what it takes to build the backend for the OneList API that you had. So I know the homework tonight is like build up the API backend part, but try just build something simple that points at your API and just loads a list of whatever it is. It's animals or something, right? Like creating an animal, updating the number of times. See if you can just at least get the list of animals loaded on the screen via a React app. Even if you go that far, I think you'll get some personal satisfaction out of seeing that, and you will have at that point seen at its fundamentals everything we want you to do for a capstone project. Stand up an API, stand up a thing that consumes it, iterate, just make it better, right? That's the first step of backend, right? This is why we tell you build the mockups, build the HTML, build the CSS. Now you're going to build a little bit of the API and make a little bit of your front end live, right? And then build more of the API and make more of the front end live, and build more of the API, more of the front end live, right? Once you get that process rolling, you're just iterating. Sometimes I'm working on the front end, sometimes I'm working on the back end, right? Add more endpoints and more tables, add more user interface to be able to click on things. Send the API request to my API that does the thing that it needs to do. That's it. Right. Hopefully it seems less daunting than it did before, maybe. Maybe yes, maybe no. Maybe yes, maybe no, right? But now we have, at least in terms of the major puzzle pieces, pretty much everything that we need. Right. So for the next couple of weeks, we're just gonna be learning more techniques on the back end to be able to do things, right? We're going to see Rails instead of Sinatra. We're going to see how to do authentication, logins, those sort of things. We'll talk about image uploading. We'll talk about a couple of those things, how to handle on the back end. But from this point, we pretty much have all the major puzzle pieces, right? Databases and connecting that to the web were the last two things we needed. I'm not saying I expect you to be able to like start working on all of your Capstone project, but you should see the major pieces, at least the major puzzle pieces, and loosely how they fit. Loosely how they fit. I'm going to commit this. Try taking your one list. Right? Create the one list database and create a items table. See if you can point your one list implementation at it. See what happens. Any questions on the second half of this, updating, deleting? Cool.